In this video, we'll take a look at how to use a trigonometric identity in order to help us solve a trigonometric equation. Here we have sine of 2 theta is equal to negative sine theta, and we want to solve this equation on negative pi to positive pi. Well, we know how to tackle an equation if we have a multiple angle equal to some value, but because the right-hand side of our equation is equal to negative sine theta, this suggests that maybe we should try to use a double angle identity and then factor to get our final solutions. So let's rewrite this as sine 2 theta plus sine theta is equal to 0. And then recall that sine of 2 theta is equal to 2 sine theta cosine theta. So applying this identity, we get 2 sine theta cosine theta plus sine theta is equal to 0. Now there's a common factor in each one of the terms on the left-hand side. We can take out this common factor of sine theta, and we're left with 2 cosine theta plus 1. So this implies that either sine theta is equal to 0, or 2 cos theta plus 1 is equal to 0. And if we simplify the second one, we'll get cosine of theta is equal to negative 1/2. So let's go ahead and solve this first equation. Sine theta is equal to 0. So we're looking for y-coordinates that have a value of 0 on the unit circle. There's going to be 2 of those, one here and one here. And since we're on the interval from negative pi to positive pi, we're going to start at negative pi. That's one of our possible solutions. We're going to go all the way over to 0. That's another possible solution. And then keep going on to positive pi. So there's going to be 3 possible solutions here. Theta is negative pi, 0, or positive pi. Next, let's try to solve our second possibility, and that's cosine theta is equal to negative 1/2. First, let's try to determine the point on the unit circle that has an x-coordinate of 1/2 inside the first quadrant. This is going to occur at an angle of pi by 3. Now that we know our reference angle, let's apply the cast rule. The cast rule tells us that there's going to be 2 possibilities where cosine is negative in the second and the third quadrant. We're going to put our reference angles over here, and that's going to tell us that the 2 angles that we're looking for are 2 pi by 3 and negative 2 pi by 3. Be careful here. Because our interval is from negative pi to positive pi, we don't want to go past pi and measure this angle in the third quadrant as 4 pi by 3. We actually have to go backwards or clockwise from 0 to get negative 2 pi by 3. So altogether we're going to have these 5 solutions: plus or minus pi, 0, and plus or minus 2 pi by 3.